The question we are going to discuss today is the taking of bunkers is an important aspect of an engineer's responsibility. State the safety precautions that should be observed when bunkering. Explain the importance of taking samples when bunkering. Explain a preferred method of taking samples. State the effect of each of the following in a fuel oil: high density, high power point, high water content. Let's start with the first part. State the safety precautions that should be observed when bunkering. Safety precautions that should be observed during bunkering. All responsible officers should be familiar with all aspects of bunkering and the ship's bunkering system, and one such officer should personally supervise the operation. He must be in close contact with the shore barge, especially concerning stopping bunkers in case of emergencies. On arrival at the bunker port, delivery documents of the fuel supplier are to be examined and compared with the instruction of the owner or charterer. Density, viscosity, sulfur content, etc. are to be matched with the ordered ones. All values should be checked and those not to be used must be securely closed. Oil absorbent materials should be easily available. Firefighting appliances to be kept handy. Scuppers should be sealed. The communication system should be checked between the ship and the shore. All hose connections are to be frequently checked. Before bunkering, sounding of the allege at shore installation or barge is to be taken and signed jointly. Ship tank soundings are to be taken. The overflow tanks should be kept empty for oil. Trays must be fitted under joints. Bunkering should start at a minimum rate so that any problem may be detected early. Tanks should not be filled at more than 90% capacity. For the last two tanks, final topping up should be done by gravity if practicable, otherwise pumping rate should be reduced. On completion, special care should be taken when disconnecting hoses and removing drip trays. Next part. Explain the importance of taking samples when bunkering. Representative samples must be collected in bottles sealed, signed and dated by both the chief engineer and the local supplier. Normally 4 bottles are collected, one for the ship, one for shore-based lab analysis, one for the supplier and one for Marpol. In the event of a genuine quality/quantity problem arising, the supplier must be advised as soon as possible. The supplier may decline to accept liability if this is not done within a specified period. The period of notification should be mentioned in the supplier's terms and conditions. In case of any problem regarding quality or quantity, a letter of protest is to be issued by the chief engineer. The sample must be representative of the total delivery and ideally taken by drip feed at the discharge side of the manifold during course of the pumping process. Samples should not be taken at the start or on the completion of bunkering because then they will not be representative of all the total tonnage loaded. Also, samples should not be from just one tank on the barge. Let's move to the explain a preferred method of taking samples. Fuel oil sampling procedure. When bunkering starts, place a container under the sampler, open the sample valve fully and flush the sampler with fuel. It is good practice to check this sample from fuel initially pumped on board, as it may be high in water content from the bunker barge tank. After flushing the sampler, close the valve and attach a suitable clean container to the valve. Adjust the needle valve to give a slow and steady drip, time the fill rate so that it will provide for a sufficient estimated sample over the expected delivery period. If the sample container fills during the bunkering period, remove it and place an empty sample container on the sampler and continue to draw a sample. On completion of bunkering, mix the sample from both containers to ensure a good representative sample from bunkering operation. Always ensure that sampler valve is fully open to allow the sample to drain. Always close the sampler valve before blowing through the pipelines on completion of bunkering. Close the sampler valve if pumping stops to prevent the sample from being drawn back under vacuum into the fuel line. Select 3 or 4 clean sample bottles. The exact number depends on the final destination of the various samples. It is recommended that 4 representative samples to be obtained from the delivery. The full cube container should be placed in the pourer box and thoroughly shaken to ensure that the contents are mixed. Attach the pourer spout and gradually transfer the contents into the sample bottles, filling each a little at a time. If more than one container was used during bunkering, then transfer a portion into each of the bottles. Complete the document labels and attach one to each sample bottle. Always have the barge operator to witness the removal and sealing of the sample bottles. If this request is refused or if no witness is provided, note this in the delivery log. Bunker collection, sampling and storage guidelines are provided in Annexure 6 of Marcode 73-78 and have been defined by MEPC 96-47, which states that a retained sample of all fuel lines as supply is drawn at the ship's receiving manifold, sealed, signed on behalf of the supplier and the master or ship's officer in charge of the bunkering operation. Retained sample is to be kept under ship's control until the subject fuel has been substantially consumed, but in any case for at least 12 months from the date of delivery. It is important to remember that this sample is to be used solely to determine compliance with Annexure 6 of Marcode 73-78 and cannot be used for commercial purposes. However, samples can be drawn at the same time for other purposes. Let's move to the next part. State the effect of each of the following in a fuel line. High density. Effect of high density. Density is defined as the mass per unit volume and expressed in kg per meter cube in SI units. Marine fuel oils have a linear density temperature relationship as opposed to water, for example, and decreases with increasing temperature at a rate of about 0.66 kg per meter cube per degree Celsius rise. Quantity calculation, separability of water and solids to select the optimum size of gravity disk for purification, specific energy calculation, calculated carbon aromaticity index, measure the ignition quality and increased index does not cause an increase in ignition delay. High power point. Effect of high power point, wax formation impeding fluidity. The power point is the lowest temperature at which marine fuel oil can be handled without excessive amounts of wax crystals forming out of the solution. At 30 degrees Celsius below the pour point temperature, the fuel becomes gel, thereby preventing flow under its weight. So more various viscous fluids are required to be heated to maintain their pumpability. High water content. Effect of high water content, wet sludge, corrosion especially seawater, possible ignition interference, displacement of fuel quantity, specific energy calculation, heat loss. Saline water is in the emulsified state has a particular affinity for high cracked fuels and heavy sludging can be experienced during purification. Water can cause cavitation in pump section and corrosion, and while in combustion space atomization can be disturbed, ignition retarded and the cylinder lubricant film diluted. Water is normally removed by gravitational separation in the fuel tanks and by the centrifuge purification system.